In this video, we will discuss about exact differential equation. Question will come, write condition for exactness, or you will be asked question like describe and derive an expression for exact differential. So, what is a exact differential equation? In physics, we use exact differential equation in thermodynamics. Equation is said to be exact if it depends upon the state function. Remember, if uh, if an entity depends upon the state function, basically in thermodynamics, then they are called exact differentials. State functions means mass, pressure, density, energy, temperature, volume, enthalpy, entropy, Gibbs free energy, chemical composition. These are basically state functions. And for these state functions, we use exact differential. And what is the actual meaning of state function? State function means the values that depends on the state of a substance and not how that state was reached. But what is a path function? Path function means it depends upon the path, but state function does not depend upon the path. But if a differential equation depends upon the path functions, then it will be inexact. Path functions means work, heat, etc. in thermodynamics. But here we will discuss only exact differential equation. Suppose you have a state function, the internal energy. Internal energy is a state function, and that is a function of suppose temperature and the number of moles. Similarly, the pressure, that is also a function of force and area, because pressure is equal to force by area. So pressure is a state function that depends upon force and area. Similarly, density is a state function which depends upon mass and volume. So these quantities like your internal energy, pressure or density, they are called dependent variable. And this quantity, temperature, number of substance or moles, this is independent variable. These are independent variable and this is dependent variable. Here this is independent variable, force and area they are independent variable, and pressure is dependent variable, like this. Suppose you take any arbitrary function z, like u, p or a rho, you take any arbitrary function z, and z is a function of two variables, suppose x and y. So you may write z equal to a function of x, y. When the state of the function changes, the change in the function can be written as dz. Suppose you have a pressure, you have a state function pressure, and when the pressure will change, you write it dp. So how you represent dp? Change in the function. That is the change of the function with respect to x plus the change in the function with respect to y. Because the function has two variables x and y, so here you have to take the change of the function with respect to x, then the change of the function with respect to y. And we can also write the change of the function z. Instead of writing f, you can write change of the function z with respect to x when the y is constant. This means change of the function z with respect to x taking y constant plus change of the function z with y taking x constant. You can write like this, or you can write like this. Suppose the change of the function with x keeping y constant is equal to m. You take another function m and change of the function z with respect to y, or with change of z with y taking x constant is another function, right, n. Then how you represent the function or change in function dz? The change in function dz can be written as m dx plus n dy. Now we vary m with respect to y and n with respect to x, because here we have varied z with respect to x and we have taken y constant. So now you vary m with respect to y, and here you vary z with respect to x. Then what will be the change in the function m with respect to y? This is called the partial derivative. That is called the variation of dz with respect to dx with respect to x, and here we vary this function with respect to y. So this will be equal to, or this can be written as second derivative of the function with respect to y and x. This is called the partial derivative. Similarly, you can represent the variation of n with respect to x like this: change of the this function n with respect to x, and we know that n is equal to change of the function z with respect to y. So this will be the second derivative of z with respect to x and y. So you see, if the change of m with respect to y will be equal to the change of n with respect to x, that means the two variables x and y of the function, of the state function, are equal. They will not change. Then it will be exact. You may either write this, or you may write the right hand side second derivative of z with respect to x and y, and second derivative of z with respect to x and y. Then the function dz, the variation of the function dz is an exact differential. If this condition will be satisfied, or this condition will be satisfied, then the function z is, when you take the variation of the function z, that is dz, then it will be exact differential. So you see, for exact differential, the state of the function is not changing. When you change m with respect to y, or you change n with respect to x, then the function have a fixed value. It is not changing. The state of the function is not changing. That is why it is called exact differential. But if the state of the function will change, that means it is path dependent. If the state of the function is changed, that means now if the variation of m with respect to y is not equal to the variation of n with respect to x, or the second derivative of z with respect to x and y is not equal to the second derivative of z with respect to x and y, then dz is an inexact differential. And in case of inexact differential, it depends upon the path function. Remember, in exact differential, it depends upon the state function, and in inexact differential, it depends upon the path function. In state function, in whatever path you follow, but the initial and final condition of the state remains same. But in case of path function dependent, the state of the function changes if you go through different paths. But in case of your state functions, it is independent of the path. So this is a brief idea about exact differential equation. In the next video, we will discuss about integrating factor, that is what is integrating factor, and how you find out the integrating factor in homogeneous equation. That means Suppose you take the equation m dx plus n dy equal to 0, then this will be a homogeneous exact equation, and in this case you can find out the integrating factor. How you can find out the integrating factor? This is also a question. So basically in the next video we will discuss about integrating factor. Thank you.